everyone, and thank you for tuning in. My name is Suzana Ayete, Account Manager for HSC and PCB's organizer for this session. As you know, safety in workplaces is everyone's responsibility. This responsibility means being aware of the risk and hazards around you and being familiar with the methods for controlling them. Every day and before every task, you must engage the three most important tools at your disposal: hazard identification, risk assessment, and the hierarchy of risk controls. To talk about this and many other issues, joining us is the PCB certified trainer, a founder of SHEQ and Food Safety Management Systems Training and Consultant, Mr. David Mutuna. Feel free to write your questions and comments in the question box in the right-hand control panel, and Mr. Mutuna will answer to them accordingly. Moreover, if you want to participate directly in the discussion with Mr. Mutuna, you can also raise your hand, and then we will unmute your microphone and you can make your questions directly to him. Please, Mr. David, you may start the presentation.
Thank you, Ajeti. My name is David Mutuna, and I will be presenting a topic on occupational health, risk assessment, and the hierarchy of control. And below you will find my credentials. David M. Mutuna. I'm a technical consultant and management system standards lead auditor and trainer. I was born in Zambia, and I'm a Zambian-based certified trainer with Professional Evaluation and Certification Board, Canada. I'm certified to deliver foundation, lead auditor, lead implementer courses in ISO 9001, ISO 22000, ISO 14001, OHS 18001, and ISO/IEC 17025 and ISO 21500. I'm a founder of SHEQ and Food Management Systems Training and Consulting, an authorized training partner with Professional Evaluation and Certification Board, an ISO 17024 ANSI accredited organization. And below here you'll find details of my contact numbers in case you want to contact me after this presentation. I will go ahead now and make a presentation. It's a short presentation on occupational health and safety. And this presentation will cover hazard identification, risk assessment, and risk controls in a workplace. All injuries at workplaces are preventable. All is required is to stop, look, and think. Safety has already been alluded to by the organizer in workplaces is everyone's responsibility. This responsibility means being aware of the risks and hazards around you and being familiar with the methods for controlling them. Every day and before every task, you must engage the three most important tools at your disposal: hazard identification, risk assessment, and the hierarchy of risk controls. Your implementation of these three principles will significantly help prevent injuries happening to you and to your workmates, and might even save a life. This presentation covers common hazards, the hierarchy of risk controls, and hazard identification. First of all, we must define what a hazard is. What is a hazard? Before we talk analyzing and controlling hazards in a workplace, it is important to know how OHS 18001 defines the term hazard. OHS defines the term hazard as a source, situation, or act with a potential for harm in terms of human injury or ill health, or a combination of these. Now let's look at the categories of hazards. First of all, we have materials, which comprises They comprise liquids like solvents, acids, and alkalis, gases, carbon dioxide, carbon monoxide, methane, etc. And within the materials also we have solids, PCBs, which is polychlorinated biphenyls, which cause skin diseases and are carcinogenic. We have also plastics and resins, fiber, glass, and asbestos. Within the materials, we also have such solids as metal, wood, plastic, etc. The next one is equipment. On equipment, we have machinery, vehicles, tools, and other devices. In the environment, we have noise, temperature extremes, atmospheres, biologicals, and workstation design, e.g. illumination, bright, dark, dusty, messy, etc. People are also another type of category. Anyone in the workplace, employees, guests, customers, or contractors. Management system is also a category of hazard. Flawed policies, programs, plans, processes, procedures, and practices. Right. Walkaround inspections usually look for the first three categories of hazards, namely hazardous materials, equipment, and environmental factors. People can be a hazard at workplace if they are not sober and focus on the work they are doing. Hazardous states caused by staff at workplaces include working under the influence of legal or illegal drugs, alcohol, etc., poorly trained or educated, worried about family illness or other problems, mentally or physically incapable of doing the job safely, fatigue, distraction, and working in a hurry. An occupational health and safety management system consists of policies, programs, plans, processes, procedures, and practices. These policies, programs, plans, processes, procedures, and practices influence or contribute to behaviors in the workplace. A flawed occupational health and safety management system contributes to 98% of the workplace hazards. Now here you find some categories of hazard as well. We have fall hazard, chemical reactions, ergonomics, flammability and fires, mechanical hazards, radiation, vibration and noise, biologicals, explosives, electrical, temperature, pressure, and toxics. We will talk about some of these hazard categories, common hazards. Depending on where you work, there will be a number of different kinds of hazards. You may not notice some of them because you see them every day. Work at height, fall hazard. Falls from height are the #1 cause of death and disability in the workplace. You must conduct a site-specific risk assessment for all work at height. Working at height is not limited to working from ladders, scaffolds, or other elevated platforms. Work near exposed edges, trenches, pits, and other depressions can be considered working at height and require the same safety considerations. Outdoor work. Working outdoors can expose you to the elements. UV light causes skin cancer and eye damage, while the extremes of cold, hot, and wet environments can cause injuries like frostbite and heat stroke. Work at height, fall hazard. And the hazard there is working at height near an unprotected edge. Anyone working here is at risk of falling. A fall may result in injury. Use a removable guardrail as an engineering control in order to reduce the risk of falling. When using a forklift, the man on the forks is at risk of falling. The risk is heightened by the driver moving the forklift. Hazardous substances, toxics. Hazardous substances can enter the body by way of inhalation, absorption, and ingestion. Their effects can be immediate or they can accumulate over a long period of time. Incorrect storage and labeling is a major factor in many incidents involving hazardous substances. Failing to read the product's material safety data sheets, or MSDSs, can lead to incorrect handling methods and inappropriate selection of PPE. Hazardous substances are implicitly dangerous, especially in the absence of inadequate labeling. Any person handling unlabeled containers may be at risk. The level of risk would normally be derived from the substance's material safety data sheets, but in the absence of this information, the risk should be assumed to be high. The risk can be eliminated, substituted, or engineered out. Material safety data sheet and labeling are administrative control measures which, when well read, will alert workers to the correct PPE requirements. Electricity. Electricity is a common hazard both in the workplace and at home. Electrical current always seeks the path of least resistance. Faulty insulation and incorrect PPE put you at risk of supplying that path, while water and other liquids are good conductors of electricity and can heighten the risk when present. Faulty or poorly maintained equipment can lead to electrocution and may even cause a fire. Noise. Noise is dangerous over long periods, deadening the cilia in the ear, resulting in permanent hearing loss. Intermittent or one-off peak noise exposure can also have serious effects on your hearing. Incorrect choice of hearing protection is a common cause of hearing damage at work. As a guide, if you are standing 1 meter away from a person and you have difficulties hearing them, the noise levels are at or above the safe threshold. Manual handling. Manual handling injuries can significantly reduce your quality of life. Back injuries are often permanent and can result from just one incident of distraction or impatience. Manual handling injuries can also occur over long duration, where repetitious movements have a cumulative effect. They are often due to poor workstation setup and incorrect lifting techniques. Fire. Fire can lead to large-scale losses and significant disruptions to your business's operations. The risk of death and serious injury is extremely high. Flammable materials in atmospheres, hot work, machinery, and electricity will have the potential to cause a fire. Attempting to extinguish a fire can be hazardous in itself when the incorrect type of fire extinguisher is used. By simply not knowing your workplace fire emergency procedure, you may be putting yourself and your colleagues at risk. And the hazards here are combustible materials stored near a high voltage source. The entire business and its employees are at risk should the fire get out of control. The risk of heavy losses demands immediate action. Most fire hazards can be eliminated or isolated, but if you encounter a fire, you need to take action that does not increase your risk of injury or death. Do not use a water-filled fire extinguisher to put out an electrical fire. A dry chemical or carbon dioxide unit should be used. Workplace equipment. Workplace equipment, including plant, machinery, and tools, are inherently dangerous. Poor maintenance and complacent attitudes can lead to serious injuries to those using the equipment and to those in the immediate vicinity. Damaged equipment must be reported immediately and should not be used until repaired. When servicing and maintaining equipment, incorrect log out, tag out procedures can result in the machinery or process being restarted by an unsuspecting colleague. The consequences can be fatal. Confined spaces. Entering the designated confined space without following the entry permit procedure is extremely dangerous. A spark or flame may ignite a combustible atmosphere. Working in an oxygen-deficient atmosphere can lead to you falling unconscious with a high likelihood of death, while toxic gases can do irreparable damage to your respiratory system. Never enter a confined space unless you have a permit to do so and have been properly trained. Identifying hazards. Now, the first step in controlling workplace hazards is to first identify them. Here are the basic methods of hazard identification. 1. Informal and formal observation programs. This is nothing more than being watchful for hazards and unsafe behaviors at the workplace. Number 2, comprehensive company-wide surveys. Use a team of outside specialists with expertise in safety, health, and industrial hygiene. Safety professional and industrial hygienist. Ask many people or staff the same questions. Number 3, individual interviews, including body mapping, a one-on-one process that asks unique questions to obtain a wealth of information from employees. Number 4, walkaround inspections, general walkaround examination of every part of the workplace to locate conditions that do not comply with safety hazards. Best understood and most frequently tool used to assess workplace hazards. This is done at specified intervals. Documentation review. Review existing documents to determine what type of hazards existed prior to the assessment. We continue with hazard identification. The process of identifying hazards and assessing the nature of their associated risks is central to workplace safety. Formal hazard identification should be performed at regular prescribed intervals and whenever new processes or equipment are introduced to the workplace. You should also incorporate these general principles into your own personal day-to-day safety awareness. Generally, you should identify hazards and their associated risks before starting any task. If you identify hazards or any dangerous work practice, report them immediately to your supervisor. Now we come to risk assessment. For each hazard, work out what harm could occur and the likelihood of it occurring. Also consider the consequences of an incident. Who is at risk and how often they are exposed to the risk. Now in this case we use a risk matrix. The semi-quantitative risk assessment method defines a risk as the probability or likelihood that an event or incident will occur. The probability and consequence is estimated to give a risk factor, which is a product of severity, frequency, scale of effect or impact, probability or likelihood. For simplicity, we shall use severity and probability. In this regard, risk equals severity times probability. And now here is a risk matrix and a risk assessment guide. Step 1, consider the consequences. What are the consequences of this hazard occurring? Consider what the most probable consequence is with respect to this work hazard. We have extreme there, multiple fatalities or permanent injuries, critical, single fatality or permanent injury, major medical treatment or lost time injury, minor first aid treatment, insignificant incident or near miss, no treatment. The second step is consider the likelihood. What is the likelihood of the hazard consequence in step 1 occurring? Almost certain. It's expected to occur in most circumstances. Likely will probably occur at least once. Possible event might occur at some time. Unlikely or rare event not expected to occur or only in exceptional circumstances. Step 3, you calculate the risk. Take step 1 rating and select the correct column. Okay? And take step 2 rating and select the correct line, or the correct line. And number 3, use the risk score where the 2 ratings cross on the matrix below. For instance, if the consequence is almost certain, and the likelihood is almost certain, and the consequence is extreme, then you go on the line of almost certain and come to the column of extreme, and you get high. That is a high risk. Another example, if the likelihood is possible and the consequence is major, then you go where the lines meet and get an M, which is medium. On this matrix, L stands for low, M medium, S stands for serious, and H stands for high. The use of numbers may be preferable. You have on the right column there severity, which I have named A, likelihood and probability, which has been named B. So on the criteria there, you go to the extreme right. On the column of score, you find 5, 4, 3, 2, 1. And catastrophic, that is fatality or long-term impact to critical media, like drinking water source, loss of property, legal requirement, toxic release, offsite with long-term detrimental effects, huge financial losses, long plant shutdown. You score that one as 5 on the severity. And on the major, on the score of 4, it's major long-term injury or health effect or permanent disability, long-term impact, non-critical media, offsite release with no long-term effects or impact, near sensitive environment or sensitive receiving environment legislation, major financial loss. That you score that one as 4, and so on and so forth. Then when you come to likelihood, you have the criteria there and constant, almost certain. It is expected to occur in all circumstances. You rate it as 5. Likely or probable, it is expected to occur in most circumstances. Possible, it will probably occur in most circumstances, or might occur at some point. You rate it 3, and so on until you rate 1. So the overall risk there is A times B. If the incident is really catastrophic, but it is rare, then it's 5 times 1, which is 5, which is a low risk. If the incident is major and it's almost it's constant or almost certain, it's expected to occur in all circumstances, then it is 4 times 5, which is 20, which is the high risk. This is how this risk matrix with the use of numbers is used. Now let's look at the risk assessment flow chart. First of all, there must be a requirement for risk assessment which is determined by management or members of the organization. And this is determined either by a new or modified system or an incident. So what you should do first, risk assessment is determined and required. Establish a team, employer-employee representation, identify hazards, assess the risk using risk matrix or worksheet, and you use the outcome or the consequences, likelihood or probability, the product of those, and then complete the risk using risk rating matrix. And then from there you can prioritize your risk ratings: extreme, high or significant, medium, moderate, low. Then you can develop and implement monitor action plans. Right. That was the schematic presentation of what you do. But here is a little bit more detailed steps towards the risk assessment flowchart. Step 1, decision to perform a risk assessment. The risk assessment may be the result of new equipment being introduced or existing equipment in workplaces being modified. Significant changes being introduced to the task performed in the workplace. Safety, environmental or business interruption control systems being modified. Regulatory requirement. Equipment that is being used for another purpose. New information about the identified hazards being available. And incident investigations revealing new information regarding workplace hazards or the level of risk or an accident. Then step 2, establish a risk assessment team. A team of trained and appropriate people covering all domains of the project assessment shall conduct the risk assessment. Team to be no more than 6. Complete risk assessment team sheet of the risk assessment worksheet. Number 3, identify the hazards. There are approximately 13 sources of hazards in the energy sector that may cause injury, illnesses, or environmental damage. These being pressure, mechanical, gravitational, musculoskeletal, thermal, radiation, chemical, potential energy, electrical, kinetic energy, biological, nature, vibration. These 13 potential sources can be used to develop the checklist of specific hazards, and site checklists are also used here. These hazards are to be reviewed by the team in order to find those that may be encountered in the assessment and the review. Step 4, assess the risk for all the hazards identified in step 3. The team has to evaluate what is the likely outcome of such a hazard. Evaluate what is likely, what the likelihood of the hazard causing injury or loss. For this, you use the risk matrix as outlined in the previous slides. Step 5, prioritize the risk. Use the risk assessment worksheet to prioritize the risk as follows: priority 1, priority 2, priority 3, even priority 4 and 5. Complete the risk assessment form on the Microsoft Excel sheet of the risk assessment worksheet. Step 6, develop action plans. Identified risks shall be prioritized for action and control measures. The following hierarchy will apply to reduce the risk as far as practicable: elimination of the hazard, reduction of the risk through substitution with lower hazard arrangements, use of engineering controls, isolation, use of administrative controls, use of PPE, personal protective equipment. Step 7, communicate the results. The outcomes of risk assessments shall be communicated to all relevant stakeholders. Step 7, retain records. Records of risk assessments shall be retained for as long as the plant, equipment, or system of work is current. Hierarchy of controls. Risk control. Implement the hierarchy of risk control to eliminate or reduce the risk to the lowest level practicable. Hierarchy of controls. The hierarchy of risk control prioritizes the step we should take to control the risks in your workplace. The hierarchy prioritizes the following the measures in this order: elimination, substitution, isolation, engineering controls, administrative controls, and lastly, but not least, personal protective equipment, or PPE. These measures can be used in combination with each other. Now here we present an example of risk assessment and controls. On the extreme left, we have a risk reference. And if you go, for instance, I'll talk about the last on the column, which is chiller compressor. Somebody or people are working in a chiller compressor. The process or activity that takes place there, among the others, is cleaning of the motors. And the hazard that might be encountered there is live components, live wires. And let's say there are 2 people working in there for a small organization. Then on the row on top there, we have description of the potential harm or environmental impact, including impact on public. Here you have electric shock, which can lead to serious injury or death. Of course, this is a safety problem. The operating condition, say machine is working, but severity factor there, you say it is 3 if you use the risk matrix of numbers. Then the probability of it occurring may be 1, and so the risk rating is 3. Existing controls, power isolation circuit breakers, emergency switches, and lockout tagout procedure in place. And wait just a minute. Yeah. Then you may need to put the target date on which the existing control or the controls may be put if they are not there, and the completion date, collection action number, and perhaps legislation cause from your legal register. Okay. Thank you very much. If there are any questions, please, they are welcome.
Mr. David, thank you very much for this presentation. We have some of the questions we would like to answer. The first question is, according to your experience, what are the most common problems that may come up during the hazard identification?
During the hazard identification, the most common problems that may come up is lack of the knowledge of hazard identification procedures. People who carry out hazard identification must be well versed with the methods that are used, as highlighted in my presentation.
Thank you. The second question is, what is your general advice for the organizations regarding the hazard categorization?
Regarding the hazard categorization, you know, many organizations, because they are not very well trained in hazard identification, they don't have a management system in place that tells employees and everybody what to do. It will be very difficult for them to actually categorize the hazards. You have to know them first, and then you can categorize them, and then you can carry out risk assessment and risk controls.
Mr. David, thank you once again. I would also like to thank all the attendees for taking the time out of their busy schedule to join us. We hope you enjoyed this webinar. We received all of your questions, and because the time is limited, we will answer to your questions individually by email. Also, don't forget to check PCB's webinar schedule on our website, www.pcb.com, or our official social media network. See you on Friday, where we will talk about ISO 40001, integrity, implementation, and auditing the new EMS standard. Goodbye.